Alright, so here I am back again. You can look in the back of the book for this, you can look online for this, but the equation for the area of a circle, so the area of a circle, most people that have spent a lot of time in math classes refer to the area of the circle as pi times the radius squared, pi r squared. That's how most people talk about circles and radiuses. Makes a lot of sense if you're a machinist and you're spinning things around the center all the time. It helps a lot with some advanced math when you're trying to find fields and stuff around symmetrical objects. And it just sticks. Most people deal with that in math, in science. In the real world, nobody, again, they don't talk about pipe by its area, and they don't talk about pipe by its radius. They talk about pipe by its diameter. And the book gives another equation for the area of the circle. They call it area of the circle equals pi diameter squared over 4. These two statements are equal, and I can show you how they're equal by taking normal, acceptable math principles to one of them and working my way to the other one, or vice versa. And I can do that here. By definition, we know that a radius multiplied by 2 equals a 1 diameter. The diameter is the complete distance across this circle, and the radius is from the center out. I mean, that's you can look up the diameter, the definition of a diameter, the definition of radius, and you can find that the diameter basically equals 2r, or 2 times the radius. If I was to solve for the radius, let's say, in this case, do a little math on it, the radius is also equal to the diameter over 2, half the diameter. If I was to substitute this r into here, I could get pi diameter over 2 squared. I just substituted this in for r, and that gives me pi diameter squared over 2 squared, which is pi diameter squared over 4, which is this equation. So I never liked this when I first started teaching the hydraulics course, because, you know, real math people don't talk about the area of a circle as pi diameter squared over 4. However, real people talk about diameters. They don't talk about radiuses. And so I've kind of learned a couple things in the teaching this class is that I like this particular equation. I use it quite a bit. And I also use the equations in the book a lot more than I used to. I used to do a lot of the dimensional analysis, think my way through these problems, but I use their equations a lot now. Okay, so let's get back to actually solving this problem. So we have an area already. We have an area in meters squared, 0.000208 meters squared, and it should equal pi times the diameter squared over 4. We need to solve for the diameter. How do we do that? Well, what we do to one side of the equation, we have to do the other. We need to multiply both sides of these equations by the number 4 to get the 4 out of the denominator and get it over here. We also need to divide both sides of the equation by pi to get it out of the numerator and get it over here. And if we do that, we're left with 4 times 0.00208, keep your units, divided by pi, equaling d squared. I'm going to crank this out on my calculator. I'm going to multiply 4 by that number, and then I'm going to divide it, and pi, again, you can look up the definition of pi. 3.14 is typically good enough. A lot of your scientific calculators, you just plug pi in and see what number we get. Oh darn, I had it on there and I erased it. 0.00208 times 4 divided by 3.14. Okay, this gives us a diameter squared of 0.00265. meters squared. Still meters squared. How do I solve for d? Because d is not d squared. The square root of d squared just happens to be d. That's nice. So if I take the square root of this side and get d, I also need to take the square root of this side. And if these two things are equal, like the equation says, take the square root of this side, take the square root of this side, I'm still not going to change that equality. So I'm going to go ahead and square root both sides. 0, 0, 0, 2, 6, 5. Square root of d squared. And I get d equal to the square root of this, which is going to be 0.01628. Now it's meters, because the square root of meters squared is just a meter. I'm going over time. I need to stop again.